Welcome back. Let's discuss interference now. Okay? So let's consider two waves, D1 and D2, each of them traveling along the x-axis. They will be traveling with the same frequency, the same wavelength, and the same amplitude, and both of them are traveling in the same direction. However, they differ in their position on the x-axis and on their phase difference. So let's write here D1. Let me call this one the position of this x1 and t, and the amplitude, I will call it little a, and it is the sine of k x1 minus omega t. I will not call it omega 1 because the next wave will also have the same omega. They have the same k, they have the same speed. And the phase of this, let me call it 1, 0. It's the intrinsic phase of this thing. Let's say if you have a speaker, it has its own phase here, phi. Okay. And d, the second one, is d of x2 and t, and it is equal to a times the sine of k x2 minus omega t plus phi to 0. Now, these two waves, when you add them, they can add constructively or destructively, depending on what's going on inside here. So I'm going to call inside here, for this one I'll call it phi 1. So this whole thing will be a times the sine of phi 1. So this whole thing, I'm just naming phi 1. And what's inside here, I'm going to call it phi 2. Phi 2. Now, if this and this, if they differ by one wavelength, then it will be constructive interference. Let me show you what I mean. So let's say both of them have, let's say this part here, if phi 1 and phi 2 are exactly the same, so here is the first wave, and the second wave will be right below it. And it looks like this. In this case, it would be constructive interference. If I would like it to be destructive interference, I would take this whole wave, or maybe this whole wave, and take it back by half a wavelength. So what happens if I take this whole wave and shift it back by half a wavelength? Well, it would look like this. Let me shift this one here, or take this one and just shift it. I will draw a third wave, where I shift by half a wavelength. Exactly the same wave, but it's shifted back. Instead of starting here, it will start here. So it will look like this. I shifted it back by half a wavelength, but look now. It would be destructive interference when I shift by half a wavelength. But if I shift by a whole wavelength, so let me shift it more. So I shifted by a whole wavelength. It's like I took this wave and pulled it back by a whole wavelength. So it goes like this, and then it starts. Let's compare this to this one and this one. Let's compare them. Well, look at that. They're exactly the same, so this will be constructive. So when you shift, if phi here, if they're exactly the same, if the difference between 1 and 2 is, if they differ by 0, or a pi over by 2 pi or 4 pi. 2 pi means one wavelength, 4 pi means two wavelengths, and so on. That's a constructive, fully constructive interference. If they differ by just half a wavelength, meaning you shift them by pi, or 3 pi, or 5 pi, or 7 pi, then it will be a destructive interference. So let's see here. So if, let's take the difference here, phi 2 minus phi 1. Phi 2 minus phi 1. And then I will just take the absolute value of that. So, yeah, let me just take the difference and then take the absolute value. So phi 2 is this, phi 1 is that. So this minus this. So it will be k x2 minus x1. And then omega t, negative omega t minus omega t, that cancels. And then I have phi 2, 0 minus phi 1, 0. Let's just call it delta phi. Delta phi. Delta phi here. Delta phi. Yeah. Let me just check out the notation that the book uses. Yeah, they call it delta phi 0. Delta phi 0 here. And this here, we call it delta phi. So delta phi is equal to, this is we call delta x, k times delta x minus delta phi 0. If you like, k is 2 pi over lambda, so you can write it as k 2 pi over lambda delta x minus phi 0. This should say phi 0. So if, let me put here constructive, if you have the following, if delta phi, which is equal to 2 pi over lambda delta x minus, or I should say plus actually, plus, yeah, this minus that, yeah, should say plus, minus, plus delta phi 0, if that's equal to 2 pi, if it's equal to 0, or 2 pi, or 4 pi, so a multiple of pi, so let me call it m, a multiple of 2 pi, so m times 2 pi, where m is equal to 0, or 1, or 2, and so on. That's constructive interference. Destructive if they differ by an extra pi, like an odd number of pi. So pi would be destructive 2 pi, constructive 3 pi, destructive, and so on. So if delta is equal to 2 pi over lambda delta x plus delta phi 0, if that's equal to an integer plus a half times 2 pi, where m is also 0, 1, 2, 3, and so on. So let's see, if m is 0, you get 0 plus a half, that's half. Half of 2 pi is pi. If m is 1, you put 1, 1 plus a half is 1.5, or 3 halves. 1.5 times 2 is 3, that's 3 pi. And so on. So this is the condition for constructive interference. All right? So let's take an example here just to make it look familiar to us. Here is the example, blue pen here. And let's read it together. So you're standing in front of two side-by-side speakers, playing sound of the same frequency, so the same omega, same F, same omega. Initially, there is no sound at all. So, or almost no sound at all, meaning they're interacting destructively. One speaker is canceling the sound of the other one. Then, one of the speakers is slowly moved away from you. The sound intensity increases as the separation between the speakers increases, reaching a maximum when the speakers are 0.75 meters apart. So when you pull one of the speakers away from yourself, then at some point, you will have constructive interference. You hear a maximum. And then that speaker continues to be moved away from you until you hear a minimum. And the question is, when do you hear the minimum again? So let's do it graphically first, and then let's think about what's going on. So here is speaker 1, and here is speaker 2, and you're here. You're somewhere here. So let's say, I'll just do this. They're interacting destructively. So let's say, we just draw a few waves. So let's say the wave from this one comes like this. This one, for it to be destructive, for the one that's with this speaker to be destructive, it means the wave from this speaker here needs to be doing the opposite of what this one is doing, and now it's destructive interference. What happens next, so this is destructive. So x for this one and x for this one are the same. They start at the same position in space. So let me just write this formula here. Okay, I'm going to write this formula. In fact, we'll write this formula and then delta phi. Let's write delta phi and then argue that it will be destructive. So I'm going to just write this. So initially, we got the following: delta phi, which is equal to 2 pi over lambda times delta x plus phi 0 is equal to what? Well, it's destructive. It means they differ by a pi, right? Not because it's the first time it's destructive. They will differ by a pi. So I'm going to call this just pi. They will equal to a pi. M plus 1/2. The first time this occurs, destructive will be when m is 0. So you get m plus 1/2 times 2 pi. So that's just pi. So that's that. But here's the thing. Initially, delta x is equal to 0, so this part here is 0, so we get delta phi will equal to just phi 0, and that's equal to pi. So the phase difference between the two speakers is simply phi. This phi 0, we just found it, it's equal to pi. So later, let's see what happens later. One of the speakers is moved away. So let's say we move the first speaker. So here is again the ending point, and here is this second speaker. The second speaker is still there. I'm going to just do this. I'm going to just do that for all of them. So the second speaker is here. Second speaker is there, and it's still doing what it is doing. We didn't do anything to the second speaker. The first speaker also, we didn't do anything to it, except we moved it out. We moved it away, and then they said when we moved it away by 0.75, we moved the second speaker here. Now it's suddenly constructive. The first speaker also does what it does. So it starts here, it sends a wave upward. Let me just draw it exactly like this way. It sends a wave upward, and then it goes downward, then upward, downward, upward. So that means when we shifted it, we have shifted it by half a wavelength, So half a wavelength happens to be 0.75 meters. So how do I know that? Let's see. It will be like this later. It's constructive now, so you got delta phi will equal to 2 pi over lambda. What's the difference now? Delta x. For this one, it's this distance. For this one, it's this distance. So it's this distance, which is equal to this one, plus the additional one. So delta x is 0.75. 0.75. And plus, right? So 2 pi over lambda, delta x, that's 0.75. Earlier was 0 because they started at the same point. Phi, we just figured it was pi. And now it's constructive interference. If it's constructive interference, it means they differ by what? They differ by a 2 pi, right? Because if it's constructive interference, they have to differ by a 2 pi. Yeah. So 2 pi here. You might say, why not 0? Well, I mean, if you plug in 0, think about it. If you put 0, you would have... if we put a negative sign here, then 0 could be possible. But we put 0.75, so 0 is not possible. Two positive numbers cannot give you a negative, cannot give you 0. Let's see what we get for lambda first. So we divide everything by a pi. So we get, by the way, 0.75 is 3/2, or 0.75 is 3/4, right? 3/4. So I have 3, let's divide by a pi here, so we got 3/4, this is the 3/4, and then 2 over lambda is plus, when we divide it by a pi, there is a 1 here, and here there is a 2. Let's move the 1 to the other side, so we'll just have a 1. Yeah, have a 1 there. If we move the pi here, it will be 2 pi minus pi. That's just 1 pi, and then you divide the pi out. Yeah. So you get this equal to 1. And let's see what lambda is. So we get 4 lambda equal to 6, or 6 over 4 is equal to lambda. So lambda will equal to 6 divided by 4, which is 3 over 2. 3 over 2. So that's lambda. Lambda is equal to 3 over 2. All right, so lambda is 3 over 2. Now the question wasn't this. They said, now you take this speaker and you shift it some more, when do you hear destructive interference again? So if we shift the speaker, so it starts here. So now for the next time, so we're going to shift it back. I'll just draw it in blue. We shift it back, so it does what it does. But now it starts here. That's where the peak goes. And here, and here, and here, and here, and here. And you can see now it's destructive, because when this one is down, this one is up. When this one is down, this one is up. When this one is up, this one is down. So they're doing exactly the opposite, so it will be destructive. So even later, when we shift again, we will see destructive interference. So shift again. You get delta phi will equal to 2 pi delta x divided by lambda plus phi 0 is equal to what? It's destructive interference. So the first destructive interference, they differed by a pi, but now they will differ by 3 pi. That's the next thing. By a 3 pi. And so they're asking what would delta x be? I think you would know it's 1.5. You shift it by 0.75 and then you shift again by another 0.75. It should be 1.5, but let's see. Let's just let the math sort itself. So you get, let me just write this part here. So you get 2 pi divided by lambda, but lambda is 3/2. So 3/2. It will flip in a moment and go upstairs. Delta x plus phi 0 we said is pi, right? Phi 0 is pi. And then here I have 3 pi. We'll move the pi to the other side, so it becomes 2 pi and cancel the, let's just do it in 2 steps. So here I'm dividing by 3/2, so it becomes 4/3 pi delta x plus what? Actually not plus, moved it to the other side, it becomes 2 pi. So it becomes 2 pi. So the pi goes away. Multiply both sides by 3 and divide by 4. So delta x will equal to 3 over 4 times 2. And that's 6 over 4 or 3 over 2, which is equal to 1.5. So that's when you hear destructive interference again. I think visually speaking, it's easier to figure it out. However, this is a reliable way of doing it. This always works, the algebraic way. The graphical way works when things are like nicely pictured, like this. When they started initially, they were out of phase. We say they are out of phase, and then we say out of phase because they are doing the opposites to each other. And then they became in phase, here, the black and the black. And then later they became out of phase again, the blue here and the black line here. That was out of phase. So that was destructive interference. So now, next, I would like to get back to this formula. I want to add these two things here. I want to add these two things. So namely, this function plus this function, or meaning this function plus this function, and see what I get. And I'm going to, you see here, I will have a sine of phi 1 plus a sine of phi 2, and I'm going to use this identity, sine alpha plus sine beta equals to this, all right? So that's what I'm going to use in a moment. So let me do that in the next board. So I'm going to add these two. Right, I'm going to add these two functions here. And then I'm going to use this identity. So I have dx1t plus dx2t will equal to a sine phi 1 plus a sine phi 2. And don't forget that sine phi 1 is, phi 1 is this and phi 2 is that. So let's see here. So I have d1 plus, or d of x1 and t plus d of x2 and t will equal to a sine of phi 1 plus a sine of phi 2. You can factor the a out, so it becomes like this. And now I'm going to use this that trig identity here. It will be 2 cosine of 1/2 alpha minus beta. Alpha is phi 1 and beta is phi 2. So I'm going to just do that. So I will have, let's see what it says. I still have the a here, so 2a. And then the cosine of what? 1/2 of alpha minus beta. So phi 1 minus phi 2. Okay? And then times the sine of, I guess, 1/2 of phi 1 plus phi 2. And so remember what phi 1 minus phi 2 was. Phi 1, or phi 2 minus phi 1 was what? What was phi 1 minus phi 2. Let me see here. Oh yeah, the cosine. Yeah, so it doesn't matter actually. The cosine is an even function. Cosine of a minus b or b minus a will be the same. So I'll put the 2 first and then the 1 second, right? Because cosine of negative x is the same as the cosine of x. Cosine is an even function. The minus sign doesn't matter. The sine is an odd function, so it wouldn't work. But for the sine, we have a positive quantity. So we have 2a times the cosine of 1/2 phi 1 minus phi 2. So that's 1/2, it would be k times delta x over 2. K times delta x over 2. And then plus 1/2 of delta phi 0. Phi 0. And then I have the sine of these two things added together. Sine of 1/2 of phi 1 plus phi 2. So you have, what is that? When you add them together, this plus this whole thing plus this whole thing over 2. So that's k x1 plus x2 over 2. So that's the average of the x's. So k x1 plus x2. Let me write just k. The 1/2 I would write it. So you have k and then x1 plus x2 divided by 2. And then minus omega t minus omega t, that's negative 2 omega t, but there is a half, so that's negative just omega t. And then plus the average of the phases, 1/2 of phi 1, 0 plus phi 2, 0, like so. Okay? And I'm going to call what's in front of it as simply the amplitude, so this is just phi 2 minus phi 1 is just the phase, like delta phi. So I would call it delta phi. So I have 2a times the cosine of delta phi over 2. And delta phi is this, because phi 2 minus phi 1, which is this, I just wrote it as delta phi and then over 2. You have the 1/2. And this will be basically the amplitude times the sine of, we have here k, times the average of x, delta times the x average, right? x1 plus x2 over 2, that's the average. And then minus omega t plus the average phase, plus phi 0 average. Just the average of the phase. And I think that's how they call it. Yeah, phi 0 average and k x average. Now, what's in front, what you notice here, this is still a wave, and it's traveling to the right with the same speed. And this is the amplitude. This is the amplitude here. Amplitude. And the amplitude changes. So the amplitude could be 0, or it could be as large as 2a. So the maximum amplitude will be just 2a, because it's maximum when this is equal to 1. And and then the minimum amplitude, the absolute value of the minimum amplitude is 0. 0, because it is when this is 0. So the amplitude will be 0 when you have destructive interference. And so we say it's destructive interference when delta phi over 2 is equal to 0. So destructive, constructive if this is equal to, when delta phi over 2, it would be constructive when the cosine gives you 1. When the cosine is 1, you get constructive. That's the maximum it can be. So, constructive, let's just try to derive that. Constructive. Let me check out the time. Hopefully I don't run out. Yeah, I still have a few minutes. Constructive if cosine of this gives me 1, that means delta phi over 2. When is the cosine 1? Well, when delta phi over 2 is equal to 0, or pi, or whatever. When it's equal to 0, or 2 pi, or 4 pi, and 6 pi, and so on. So we have the, I want the maximum amplitude, so just the magnitude of this. Even when the plus and minus, that's a maximum displacement, so it's still the maximum amplitude. The minimum amplitude when the cosine gives me 0. So when delta phi over 2 is a multiple of pi, so that's constructive. Delta phi over 2 is a multiple of pi, which we call m times pi, and so delta phi is equal to m times 2 pi, and m is equal to 0 or 1 or 2. That's constructive. Destructive, if the delta phi over 2, when is the cosine equal to 0? Well, it's equal to 0 at pi over 2, 3 pi over 2, right, 90 degrees, 270, and so on. So when it is a multiple of pi over 2, so it's m plus 1/2 times pi. Notice, if m is 0, you get half pi. If m is 1, you get 3/2 of pi, which is 270, and so on. So delta phi equal to m plus 1/2 times 2 pi, and m is 0, 1, 2. Okay, so that is for constructive interference. We did it the first time here, just qualitatively in here. But here it came out from the trigonometry and the algebra here. All right, so that is that. So I'm approaching the 30-minute mark. I will pause the video here, and then in the next one I want to do a quick example and talk about interference in 2 dimensions. Okay, And so the next video should be quicker one.